Thank you so much, Julia, for your presentation. And now it's time for our last competitor, Maxime from the Lycée Michel Rodange, Luxembourg, with his project Miras. He created and developed an atmospheric ion engine, which operates using electrohydrodynamic thrust. Come on, Maxime, tell us how you did it. No? This is what you wrote.
This was not the right description, but it doesn't matter. Okay, hello everyone. I'm here to present to you Project Miras. We're going to start with a quick question. I guess most of you have already dreamed that at night some magic creatures come and just clean your house and tidy everything. Well, with my project, I aim to make this a reality. Then instead of using just a regular robot that can't adapt to specific room layouts, I'm using a modular self-assembling robotic system. What are those? Well, those are composed of different modules. Each module has very limited capabilities. But once you assemble them into a bigger structure, this entire structure is highly adaptive and flexible to any kind of scenario, because it can reassemble itself and be ready for the next task. While researching, I stumbled upon three main problems in current modular robotics projects. First one being just the size of a module, as they tried to fit every single component inside of them. Afterwards, there was also the problem of degree of freedom, so they couldn't move enough to be able to move around on their own. So once they are disconnected from the structure, they will just be left behind. And finally, searching online, there was a complete lack of big simulations with hundreds of modules, which really can't show the entire the structure is even capable of. So during my project, I tried to solve those three big issues. This is my own design, inspired by a movie you might know, Big Hero 6. So in the center, you have all of the components, two legs for the movements. The first question was, how do they attach? Well, using electroadhesion with two metal plates and a polymer layer in between, I can create an electrical field that's strong enough to have a viable connection. Afterwards, I just designed the movement, so the need to be completely free and have a really like 360 degree of freedom. So each leg can move up and down, but also the entire center that can move around. At first, I just started with theoretical proof of the electronics to move on way faster towards the simulation. I have a Arduino, one of the tiniest microcontrollers and some of the tiniest gear motors in the world. Afterwards, once I had the component, I switched to making a real 3D model with the real sizes of the components. And once I had this model, I could check the sizes to make an approximate one. The first simulation was just to make it walk around, and there I wanted to hard-code it myself, but it was really slow at first. I could have tweaked the variables for hours, but I had the idea to use a reinforcement learning agent that would do this for me way faster. Using OpenAI Gym, I used one of their environments, just tweaking some of the settings, which wasn't all that difficult. And once I had the right agent, I could then transform it into Unity. Unity is a like physics-accurate engine, normally used for game design. And at first, I had no idea how I wanted to control a huge amount of them. So I started little by creating some of the basic structures you see right here. There are tons of structure possible, and I'm sure some are more efficient than others. But I just started and found those. At first, I did like 2D ones, then switched to 3D. But for 3D, it's really difficult to imagine the structure on just a computer screen. So I had the idea to implement a VR application on a VR headset. I used a feature that's called pass-through, which lets the user see their immediate surroundings in the VR headset. And additionally, when opening the application, it creates a 3D mesh of the surroundings, which allows to interact with the actual objects. Else, if you shoot something, it would just pass through. The first feature was just putting my 3D model and being able to make it bigger and inspect it. This is in my garden, and the actual object doesn't exist, right? Everything works with hand tracking, so no need of controllers. And this is possible through the cameras that track the position and rotation of several points on the hands, and then recreate those gray hands over mine. And then the initial idea, to be able to make better structures, just spawning new ones of my module, and then being able to adjust the angle, and then you can just put new ones, etc. Once I have a nice structure, I can then export it onto my laptop to use it later. Here you have just a basic simulation of how the first connection is done. What? Okay, it doesn't work. No, it doesn't matter. And then to help a module to go on the second floor, how does this work? Well, there is a helper module that actually pulls the other one up and then can disconnect. So it really makes like a chain that can go infinitely. But why did I, to make even bigger structures, it was still tedious work. So I had the idea to use voxelization algorithms to turn a normal 3D model into a voxelized 3D model. Basically, it takes the polygon mesh and makes little cubes out of it. And those cubes, I can then replace them with some of my basic structures to make one that seems just like this 3D model. Of course, it's not as accurate, but it's great for having easier control over them. Why did I even choose to do this? Well, first, there was the tidying of rooms, but it's really strong for its high adaptability and flexibility. In comparison to traditional robots, it can adapt to an environment that you can't predict before. I picked 4 of the best examples I could find. So first one, just to stabilize damaged structures like bridges or ruins. So you can have some supports that come in fast and are adaptive to that structure. Lately, to just move objects around, to pick up objects, to manipulate objects, and for example, to assemble furniture. There again, there are so many different like IKEA furniture. You cannot build one robot that will be able to all of them. So here it can adapt to the specific furniture. And finally, just to explore environments where you're not sure what's going to be there. To conclude, yes, I solved almost all of the 3 issues that I told you before. Only the size, I'm not so happy about it. But that's all right because I'm only using components you can buy online. And I can change the motor placement. I believe this will reduce size still. Around tons of applications that could be use cases for this for these systems. Finally, my future plans are just to improve the AI, because right now it's only moving forwards and backwards, and it can't really turn around. And as the center rotation, it could be working to move on planes that are slightly rough. Find more structures. Now with my VR application, this can be done more easily. And the final construction of a module would be really like the ultimate goal, to have a prototype ready. But therefore, I need to check a lot of stuff. Yeah, thanks for listening.
Hello, Maxime. How are you doing now after your performance on stage?
I'm feeling all right, thank you.
Did you feel like it went well?
Yes, absolutely. Everything was fine. No difficult questions.
Very good. We're not going to give you any difficult questions either. One thing I want to know from you is, where did you stumble upon this subject of modular robotics? Where did the idea for the project come from?
Yes. So I didn't have time to put this in the presentation, but on my poster there's like a big image of the movie Big Hero 6, and it's actually from this microbot that I was like, does this already exist in reality? What is possible? And then I searched online and I stumbled upon the field of modular robotics.
Very cool. And it is not the first time that you're participating. And did you feel like there were some expectations on you? Did you feel some pressure to perform as well as last time?
Well, last year I had made a project for myself at home. And just like last minute, I learned about the entire thing here. So now that it's the second year, I was sure that I would participate. There was a little pressure, because I didn't have a fixed project like 3 months before, but I had worked on a lot of different parts that were afterwards super useful for the entire thing.
Okay, and let's say now you would participate a third time next year. What would you do differently than this year?
So next year I would certainly continue this year's project, trying to make a real prototype and seeing how things go. Yeah.
So you have experienced already a very prestigious international competition, ISEF, in Dallas, Texas, last year. What would you recommend to the participant this year who will go abroad to international contests?
Just have fun, really, because you won't have time to change your project until then. So just take it as it is and really learn from other projects. I think that's the most amazing part.
What was the most difficult part in doing your project?
Right now, well, I have a lot of different parts that combine make this project, and in each part there are huge problems always. I guess one of the biggest problem I'm gonna face is just the energy distribution in the entire system. At first I wanted to just have current pass through like one of the ones on the ground and then go towards all of them, but then there wouldn't be such a good distribution, so I need battery modules that can move around inside of it, etc. So it's not gonna be so easy.
I see that you've learned a lot in the field of robotics from your projects. Now I want to know, do you feel like you personally also have you grown through this project? What personal skills have you learned?
Well, it's a combination of tons of skills. So I had 3D modeling, programming, now virtual reality also. I had a lot of skills that I learned already from last year that I could use this year. But main focus was on electronics and robotics. I had no idea about, but I participated in the CanSat competition last year, where you shoot a little can that's a mini satellite inside like 1 kilometer with a rocket. So there I learned a lot about microchips and.
Very good. And any soft skills that you acquired, like for example presentations, because you did really well?
I did a lot of presentations in my lifetime already, thanks to school, other activities. So yeah, that's a skill I can use also here.
Very good. And now you did the projects on yourself. Could you envision doing it in collaborations with other people?
Yes, I could imagine if it was people like Shashimia, which are amazing participants, but they would have to be as motivated as me. And if I don't feel that they're as motivated, it's gonna be hard. So.
Do you already know what you want to do after high school?
The problem is I've got so many interests that I'm not sure. I need to cut down so much that for now I'm just not deciding yet.
Mm-hmm. But for sure you will participate next year, right, to the contest?
I hope, yeah.
And do you already have an idea?
Well, as I said before, just continuing this project, trying to build the first prototype,
Okay.
and more simulations and even more structures, because I'm sure there are more efficient ones.
Do you have any tips for people that think about participating and are not sure yet? What would you tell them?
Well, you have to go through the entire thing. So if you start, then you will have to make the reports, the presentation, and the poster. So you really need to be sure about it. But it's really fun and amazing once you're here.
Very good. Well, thank you very much.
Thank you.
And
Congratulations.
congratulations.